Welcome back. We're continuing to touch on a topic called compositions, and in this section we're going to introduce a different notation for compositions of functions. So here we go. Next example is we have this. And I say this because we don't know how to read this, but it's actually nothing to write home about. We know how to deal with compositions up to this point. This is f of g of x. That's just how it's read. We have f of g of x, and what we're simply doing is we're plugging in the function g of x, the second function, into the first one. So we can also write this as f of g of x. All that means is we have a function inside a function. All right, so what we're going to do is we're going to plug in the g of x function into the f of x function. In essence, we're going to plug in x minus 2 everywhere we see x. So where we used to plug in a value for x, we're going to plug in an expression or a function into x. So we have f of x minus 2. All right, not a whole lot. Don't get excited about this. We're just plugging in x minus 2 everywhere we see x and our f of x function. So let's go ahead and do that. So we have 3 plus 2 times x. X is x minus 2. We're just plugging in the expression in for x. Minus x squared, so minus x minus 2 squared. And this is f of g of x. All we have left to do, since we have a x right here and not a value, we just simplify this out as much as we can. So let's go ahead and do that. Let's go ahead and distribute this 2 into the parentheses. So we have 2x, 2 times minus 2 is minus 4. Minus, now we have x minus 2 squared here. If you remember way back in the order of operations, the exponent comes before subtraction. So let's go ahead and deal with this first by squaring out x minus 2. Anytime we have a value or an expression squared, it's that expression times itself. So we have x minus 2 times x minus 2. Oops, excuse me. Now notice this isn't x squared minus 2 squared. We're not distributing an exponent into the parentheses. We're squaring out the entire term, so let's not get confused here. All right, so let's go ahead and continue simplifying. We have 3 plus 2x minus 4. We're still working on this bit. So what we can do here is actually multiply this out. We're going to multiply each term in the first times each term in the second. We did this in the previous section. We'll later do a whole slew of videos on factoring, which will actually be a simpler version of multiplying this out. But for now, we're going to multiply each term in the first times each term in the second. So multiplying these, we have x times x is x squared. X times minus 2 is minus 2x. And multiply each term by minus 2 into the second one. So we have minus 2x. And minus 2 times minus 2 is a positive 4. And now we can go about distributing this minus sign into our parentheses. We're just essentially multiplying each term in the parentheses by a minus 1 if you want to look at it like that. And let's go ahead and combine these two terms here, the 3 and the minus 4. So we have minus 1 plus 2x. Mark out those terms. And now we're multiplying each term in the parentheses by minus 1. So we have minus x squared plus 2x plus 2x minus 4. Multiplying by minus 1 just flips the signs of these terms. All right, now we have some like terms to combine. We want to put the biggest exponent out front and put them in descending order. So we have a minus x squared here. 2x plus 2x plus 2x is plus 6x. And we have minus 1 and minus 4, which is a minus 5. And that's all there is to it. So this is f of g of x. We're inputting g of x and we're substituting it into our f of x function. We're just substituting in g of x into x in our f of x function. So it's a function inside of a function. Now let's look at the opposite. Let's say we want g of f of x. Well, here we're going to be plugging in the f of x function into the g of x function. So we have g of f of x. That's what we want to find. So everywhere we see x in our g of x function, we're going to plug in this expression, this function. So we're looking for g of 3 plus 2x minus x squared. So let's go ahead and find that. So everywhere we see x in our g of x function, we're going to plug in this expression. So we have 3 plus 2x minus x squared, putting them in parentheses, so we can clarify that we're substituting here, and then we just have minus 2. So this is x minus 2 when this expression is plugged in for x. All right, we can actually drop our parentheses here because we're not multiplying anything by a negative, so 2x minus x squared, we're simply subtracting 2 from this expression, and this actually is quite simple. We put our minus x squared term out front, we have plus 2x, and then we have 3 minus 2 is just plus 1. And that's all there is to it. That's g of f of x. Now, as you can see in comparison to the composition in this previous example, we must handle function composition in the correct order, since these are definitely not the same answer. So we want to make sure that we're plugging in the correct function into where it's supposed to go. All right, let's look at a few more. Let's get a little more practice dealing with these compositions. Let's take a look at, using these two functions, let's take a look at g of x. All right, don't get excited here about the same function appearing twice. We'll handle this composition the same way. All this means as we're plugging one function into itself. So we have g of x. So everywhere we see x in our g of x function, we're going to plug in x minus 2. So we're looking for g of x minus 2, which is x minus 2, plugging that in for x, and then we just have minus 2. We can drop our parentheses, x minus 2, which is the same thing as x minus 4. All right, so don't get excited when you're plugging in the function into itself. That's actually quite common, and it works out pretty much the same way. Not a whole lot to it. Let's go ahead and look at one more before we move on. We have g of f of 2. All right, now here this composition has a number we must evaluate. It's going to work the same way, but instead of simplifying, we're going to be plugging in a number at the end. So this is the same as g of f of 2. We're plugging in the evaluation f of 2 into the first function, g of x. So what we're looking for is g of the function f of x evaluated at 2. So we have 3 plus 2 times, we're plugging in 2 for x. This is f of 2 minus 2 squared. Okay, not a whole lot to it. Let's go ahead and work inside out. We have g of 3 plus 2 times 2 is 4, so 3 plus 4 is 7 minus 2 squared, which is 4, which gives us g of 7 minus 4, which is g of 3. And now we simply find g of 3. So we plug in 3 everywhere we see x in the function g of x. So we have 3 minus 2, which is just 1. Okay, so just taking it one step at a time. The most important thing about compositions is knowing which order to put the functions in. This is the first function, this is the second function. So as long as we plug in the functions in the correct spaces, the correct spots, we actually know how to do the rest. It's simple algebra. So look over these composition videos a few times, especially if you plan on going into higher mathematics such as calculus, because you'll want to be quite familiar with them. So I'll see you soon.